So hello everyone, welcome to the deployment series. So currently we are on the stage that we have built every possible API, a public API, a private API, or a local API if you want to do so. But you will be asking me, how can we make it fault tolerant? Now what fault tolerance means is right now on the current stage, if I just switch off my laptop, my API is gone. What can I do that? What can I do to avoid that? So in today's video, that's exactly what we are going to see. Okay, 1 second. I'll not be going into the AWS part of this project. You can just do that. I'll just tell you how to run it on AWS itself. And yeah, I'll be doing it in my local machine, but you can do that directly on the AWS EC2 instance. I'll just tell you the steps verbally and just show you the demo locally. Okay, I hope you have understood what today's motto is. If you didn't, we are making our app a Dockerized app. That's it. And yeah, you'll be asking me how you are using everything, the Docker file contains only 5 to 6 lines, why this much tutorial and all? No. Understanding Dockerfile is one hell of a skill, and yeah, deploying apps with Docker is another. So yeah, in today's video, we're just going to see that. And if yes, we are going to just push our image into Docker Hub. Let's see how this goes. If it is not possible, I'll just tell you how. Okay. So without further ado, let's get into it. I'm Athro from Analytics. Let's go. Okay. So welcome to the tutorial part of this project. As you can see, we again have the Docker, not Dockerfile. Let's just ignore it for a while. Okay. So we have the same diabetes model that we are going to work with, and we are working with it from last 2-3 videos, if you do so. And if you don't know how to make a fast API using your ML models and all, you can check those videos out. If you do so, you will be able to implement your own fast API for your own model, machine learning model. May it be a TensorFlow model or may it be a scikit-learn or PyTorch model, doesn't matter. Okay, so yeah, we have that main.py file that our app apps API contains, which will be holding our inputs in this model input class. Then it will be loading our diabetes model using pickle, as you all know. And as before, we are making an post request endpoint, the diabetes prediction. And we are defining a function which will take all the inputs from the JSON, and yeah, that's it. Okay, so I think there's one thing missing here, the key thing, the JSON thing. Let me just check it out. And yeah, not this file. It should be ML public API. No, that's not the app actually. ML API, that's the app. Let me just open it. Yeah, exactly. I'm just going to copy this, and we're just going to paste it here itself. What we do is not very ethical, but okay. Just 1 second. What happened was I did the model for the local, but in terms of making it available to the public and accessing it with another file, it should be yeah, a hell of a journey. So that's why I would just do this instead of doing that. Okay, so this is it. Yeah, that's the previous app. If you want to check that out, also you can check that out from the description, or it should be available on the channel itself. Okay, so as you know, what this app does, it is a fast API and it takes all the features as inputs in this model input class that inherits the base model class, and then a diabetes model is loaded using pickle. And the last time it was a SAV model, this time it's a .pkl model. It is same actually, but yeah, no worries about that. Okay, then the post request, you can also use a .sav model, it doesn't matter. Okay, post endpoint containing diabetes prediction as the endpoint. Then the function which takes the input parameters, then converts them into JSON, and then again it is then loaded into a dictionary, and then every value is extracted into its separate column, and that column is converted into an input list, then predicted using the predict function. And lastly, if the prediction's first index contains 0, then yeah, obviously it is not a diabetic person, otherwise it is a diabetic person. Okay. Okay, so what should we do now? So first of all, we will create a requirements.txt. I have already created it. I'll just go through it for you. And as you know, this is the app structure. The diabetes model is sitting inside the trained model section. And yeah, we'll just create a Docker file for that. Okay, so what is a Docker file? Let me just go to the Excalibur. Then I'll just, yeah, that should do it. Okay, what is Docker and why Docker while deploying our app? So as you know, we have our machine here. Okay, suppose this is your laptop or this is your PC, doesn't matter. Okay, what if this is your PC and you have some kind of 3 versions of Python running onto your machine? In my case, it is exactly the case because yeah, there are 2 environments, Python environments, 3.11.6 and 3.12.6. Why? Because I work with several technologies, that's why. Okay, so what Docker does is, what usually happens is when you run one app, it may get conflicted with another runtime. So what if my app takes Python 3.9 as this app will? What if my app takes Python 3.9? And what if my client's runtime is 3.11? He or she would be saying yeah, it is not running, but I would be giving that famous dialogue that it runs on my machine, but I don't know what happened on yours. Okay, so to avoid that, what Docker does is it creates an isolated environment in your own machine. Okay, so this is your PC, and this is the Docker environment that would be isolating everything from your PC while running on your PC. That's the beauty of Docker. And obviously, it will not get conflicted with any other files onto your PC because this link is not attached. We can attach it, but yeah, to a specific port, and we should do it in order to access that app through our local host. Okay. So now what happens is what we will do is we will go to our app. I'll just put this, let it just be 3.12, and let's go to the Dockerfile and let's set it up. Now to set up our Docker container, that isolated environment, we need our operating system, right? So we will just get our operating system using from. It is called a base image in the Docker, in the Docker terms, but yeah, you can call it a base OS or anything. So I'll call it base image. So we will pull a base image, get a base image that has Python 3.9 installed. Okay, so it will be a Ubuntu machine in order to run your Python app. Okay, so get a base image having Python 3.9. As I said earlier, this app takes Python 3.9. We can directly write Python 3.9. Sorry. Python 3.9, and I'll just do slim. Why slim? Because I don't want my image, like the container image, to take more space. Okay. So from Python 3.9 slim, we will now initiate our working directory into that container. So we will do work dir. Let's just say init working directory in the container. Okay, that should do it. And work dir is usually app, is called app. Okay, then we will copy everything from here to the container. Copy files to container. Okay, so now firstly what will happen is let's just copy those files. So from /product. Okay. What this does is it copies everything from the current PC directory into the app directory, the dot directory. Okay, so now what happens is what we will do is install our requirements. Okay, so we will run pip install -r requirements.txt. Okay, that should do it. So now after installing everything like the requirements, we will expose our apps port with our PC's port. As I said, that environment is totally isolated from your PC, so you will not be able to like access it with your PC. So there should be a certain endpoint that you can access and not the whole app, which would not create any conflict but still be like accessible through your PC. So we will just expose the port 80 for this app. What port 80? Why port 80? Because our app works on HTTP protocol and HTTP uses port 80. That's all. So I'll just give it a name like comment. Expose port 80 to host PC in order to make app accessible through HTTP. Okay, and lastly we will run the app. All the things are set up. Now we will run the app. So for running the app, we will do cmd. So now you will be asking, why run here and cmd here? You can type cmd only once, and you can type run, like you can set up run as many times as you want. Run is usually used for installing dependencies, then configuring them, upgrading your machine, etc., for that purpose. While cmd is like a last thing you should do, that is running the app. That's why cmd. Okay, so what was our command to run? Anyone guesses? Our app is a fast API, right? Our app is a fast API which runs on what? Which runs on port 80, right? So what we will do is, it is what, the app is a fast API because That's why we are using ubicon. Then what's the command to run our app? Main colon, and our app is initialized with app. So copy this, go here, paste it here, done. Okay. Then we will initialize a host, dash dash host, hyphen hyphen host, I should say. What? 0.0.0.0. Okay, anywhere. Then what? Port, again hyphen hyphen port, and we will initialize it with 80, and that should do it. Okay, that is it for your Dockerfile. Let me just give it a comment as run the app. Okay, so now that is everything for your Dockerfile. Now what should you do in order to run your app? Like if you are on Windows, you should install Docker Desktop and run it. Okay, because Linux doesn't, like Windows doesn't come with a Docker engine installed, neither Linux, but yeah, you can like, first of all, let me just remove any images around, and yeah, let's do it. Yeah, okay, so what was I telling? That Windows doesn't come with a Docker engine installed, neither does Linux, but in Linux you can just install it by a sudo apt-get install. Like, let me just tell you here into VS Code, like by doing sudo apt-get install docker.io. Okay, and then after that, what you should do is use a mod $user -ag docker and new grp docker. These are the commands if you are like on the Ubuntu machine also. Okay, in Windows, simply install Docker desktop, I mean, and you'll be like having this beautiful app running onto your machine. And now we can work with Docker. You don't have to sign in, by the way, and I'll not, because I'm currently logged into my Ubuntu machine and it will just complete. That's it. Okay, so let me just delete these files. Okay, if I just save this now and open a terminal, now as you can see, our Docker file is in the app folder. So we will do cd app folder. If we do ls, you can see the Docker file is there. Now if I do docker, what? Now take this in your mind. Dockerfile builds a Docker image, and the Docker image is then ran as a container. Okay. In other words, you can say Dockerfile contains instructions to build a Docker image, which then runs a Docker container, a Docker image. Okay. So we'll just build a Docker image. Docker build -t to give a name or a tag to that image in Docker terms. Okay, I'll just call it the diabetes underscore app. Okay, and where are all the files for that app? In the current directory. So a dot. Okay, now if I run this, it should build fine. It will now just load some metadata for the image and pull that Python image from the, what do you say, the repositories online on the cloud. Okay, and yeah, you should be able to like run your app now. I hope everything goes fine. It is currently installing all the dependencies. As you can see, we are in the fourth step, the pip install -r requirements.txt. Okay, let's see what happens. It will obviously take some time because, requirements. Okay, everything is great. Now let me just go it up. So if I just do docker images, as you can see, the diabetes app latest is just built 11 seconds ago, and it has a size of 470 MB. If you did not specify this slim, you should see the image as 1 GB or so. Or if you just do Alpine here, the ALPINE, Alpine, you should see an error. I think so, because Alpine, I think, is not able to install the dependencies on its own. Like, it does not come with a pip installed, that's why. It does come with a pip installed, but I think it is not able to install the requirements.txt. I don't know what is the deal with that Alpine thing, but its image size is very less than this one. If you want to see that, I can just do that. Let's just do Alpine and let's see if this runs. So again, if I do, what happened? Okay, let me just clear this, go here, then do docker build -t the diabetes app, but okay, cd app folder and now build. Okay, the Alpine actually is able to build it. Yeah, actually it is. Okay, no worries. Yeah, okay. So as you can see, it is now like, no, I think it will not be able to. Let's see what happens. Okay, as you can see, it is not able to handle the installation, and obviously we need a slim image, that's why. So that's the thing you should be taking care of. So if I do docker images, there should be only one image. Okay, so now let's run that into our machine. Okay, so if we do docker run -d -p, what -d does is it runs the container in detached mode. What detached mode is? Detached mode doesn't lock your terminal to that image, so you would not be so you're able to use your terminal while the container is running in the background. If you didn't specify that -d, like the -d, your Docker images logs would be able to just come up in your terminal itself, and it will block your terminal, and it will block you by locking that terminal access to that app only, and you'll not be able to use that terminal window itself. You would be able to you would be forced to create a new window and do other stuff with it. Okay, so no matter what. Okay, so what this -p does is it specifies ports for your app. So our app runs on the port 80, right? So the port 80 of your host machine should be linked to the port 80 of the Docker image. That's what this 80:80 means. Okay, so let's define a name to this image. So to this container actually. So diabetes_app, and let's give it an image. So diabetes_app and run this. Okay, so it should be running fine. So if I do docker ps, as you can see, the app is running. And if I go to the browser, do localhost:80, seriously, okay, localhost :80. Yeah, as you can see, the detail not found means obviously this is an API, so it will not give you a UI or so, and your API is good to go. So now what we will do is we will try to access that app. So if we go to the Fast API section and go to the API implementation and open this, again Control A, Control C, close this, go here, app folder, do access api.py and paste all of this. Okay, so what this does is it imports JSON request and usually takes all the data from the user and then converts it into a JSON format and then gets a response from the URL. So what's the URL for our API? Do you know? Yes, exactly. So if we go to localhost 80 again, why does this go to the Google search? I don't know what happened. Okay, so localhost 3000, no, the 80, okay. /libraries underscore prediction. Yeah, the method is not allowed, as you can see. Okay, if I go to the VS Code and just update this URL to be localhost, Control V, okay, HTTP request, okay. Okay, so if we do this and run the app, as you can see, our app is running. So label 1, result, the person is diabetic. So now, how can you use this Dockerized app to your advantage? Go on AWS, go on and create an EC2 instance. A T2 micro will work for this, to be fair, and keep it running 24/7 every month, every year, and like get that public API, that instance is public API, and do :80, put it into your UI or something like that as a URL, then try to like send it data, receive some request, etc, etc. And or to be fair, you should be able to access your API throughout the year, throughout your lifetime, if you just keep that AWS instance running, the EC2 instance, I mean. And yeah, that was everything to my knowledge that should be done in this video in order to make you understand what Docker is, how can you run your ML images using Docker. And yeah, I hope you have enjoyed, and if you did, please hit that like button and subscribe to PyAnalytics YouTube channel. This is Atharva from PyAnalytics, and I'll see you guys in the next one. Bye bye.